Hello and welcome. We have here SOHCAHTOA. Is it familiar to you? All right. Don't worry if it's not, because we are going to apply one of these to solving these problems. SOHCAHTOA is just a shortened way of writing the trigonometric ratios that are used to solve problems involving finding missing lengths in a right angle triangle or an unknown angle. Okay, so now SOH, which is so, simply represents sine of the angle sine theta equals the O is the opposite side of the right triangle and H is the hypotenuse. Then K is representing cosine cos theta equals the adjacent side of the right triangle all over the hypotenuse. Then you have the TOA, which is tangent of the angle tan theta equals the opposite all over the adjacent. Now, how do we know the opposite side of a right triangle or the hypotenuse or the adjacent? It's very easy. Let me use this question here as an example. All right, in a right triangle, you have three sides. You have the side which is facing the right triangle. This is the right angle. It is usually called the hypotenuse. And if you have a given angle in the right triangle, that side facing the angle is the opposite. And then you have the third side. The third side is usually the side beside the right triangle and the given angle. So it's called the adjacent. So now, in any given question, you will now need to find which of the ratios best fits into the question to finding the problem. Okay, so now in this question, we are to find the missing length x in this right triangle. I'm going to show you how to determine which of these ratios to use to find the unknown length. Personally, when I'm solving problems like this is how I go, and I'll show you. So I will identify what I need to find. I would identify what I know, that is what I'm given, and then which of the ratios I will use. Now, what do we need to find? We need to find this unknown length, which is x. What do we know? We know the hypotenuse, and we know the given angle, which we call theta. So what do I use? This now brings us back to this SOHCAHTOA. We know already that our sine theta is opposite over hypotenuse. This is the opposite, this is the hypotenuse. If we use this, considering that we have a given angle, it doesn't relate to the unknown we are to find. So that cancels this ratio out. Now we move on to K, which is cosine of the angle. Cosine, the theta, we have it, fine. The adjacent, do we have it? No, that is what we are to find. Do we have the hypotenuse? Yes. So that ticks it that we can use that ratio. If you want to consider, since we already have a formula, but for tan, we can't use it because also the opposite is not known and we have to find the adjacent. So we can be finding two unknowns. So that also strikes it out. Do you see how you can determine how to use the ratios to solving problems? Now we begin to solve for this unknown variable using the cosine ratio. If you have followed me up to this point in this video, I sincerely appreciate you. And if you are yet to subscribe, kindly support me by subscribing to my channel. Put on your post notification so that when next I post any video, you will be the first to see it. Thank you. So our cosine ratio is given as cos theta equals the adjacent side all over the hypotenuse. Now cos theta here is 40.5, so we have cos 40.5 equals the adjacent is unknown x all over the hypotenuse, which is 18.7. What do we do next? We cross multiply. We now have here 18.7 cos 40.50 degree equals x. If you choose to use your calculator to find cos 40.5 or you use your cosine table of values. You have 18.7 times cos 40.5 give you 0.7604, and this equals to x. Now let's multiply. If we do that, we arrive at 14.22. Now, we can choose to leave our answer in this form, but because our hypotenuse is in one decimal place, let us also approximate this our missing length to be in one decimal place. So it becomes x equals 14.2 centimeter to one decimal place. And this is our answer. I hope you found this very easy to understand. If you did, please do not forget to leave me a comment, like, share, and subscribe. Bye bye, and see you in my next video.